Okay. So as Dan was mentioning earlier, that um, this is a area of the application that we've added to in the last year, especially with moving um, the execution side of things, the application that was being used for the PFEP execution to a Android environment. But before we get into that, I just wanted to basically go through the entire PFEP process in Proplanner and explain how this works, and touch upon the points of why there are many of our clients and customers are asking for features in PFEP, asking for the PFEP system in general. I think if you were in the morning sessions, you would have heard Andy from Lilium talk about uniqueness of Proplanner of having both the process planning solution and plan for every part of PFEP put into the same system. So kind of dwelling onto that and explaining why folks are looking at our solution, what features it has to offer, how it works, and then I will end with the new application that we've developed. So what is PFEP? PFEP is plan for every part. It's a lean manufacturing terminology being used with many of our customers now. It's basically an in-house definition. Definition of in-house logistics, right? So what parts are you receiving? Where are they being received? Where are they being stored initially? How are they being moved to the line? Are there intermediate storage locations that they go through? And finally, how do you deliver them to the line? You just directly put it on a cart? Is it a call made by the line? Is it a periodic delivery, and so on? So basically, all of those definitions that go into managing parts and their delivery to the line fall under this PFEP plan. Typically a part will, as I said, visit multiple locations. I mean, multiple delivery methods, from carts to containers to pallets, trucks, and so on. So we define all of that, right? We're defining the locations, we define the delivery methods, we're defining the storages in between. To do that, Proplanner currently supports two different types of call methods. One is a direct call made by the line, which is your Kanban, where someone on the line is requesting for a replenishment of a set or a fixed amount of parts based on a bin being empty or a couple of bins being empty. And then the other one is a scheduled delivery, which is kitting, which is more configured to the unit being built, and the delivery of these kits to the line are time bound or have a periodic repetition tied to them. Along with the delivery methods and delivering the parts to the line, we also have some tools that help you track your entire PFEP process. So we have the scheduling of the carts, and we have dashboards that tell you the status of picks, of deliveries, of transits, of skips, and so on. We allow you to print labels out of the system for tracking your carts and your containers. And then, of course, we report all of this data so that you can do more analysis on how your entire process is working. The backbone of this is obviously our assembly planner system and our shop floor viewer. This is something that you've been seeing all day today. Is we have multiple execution systems from the add-on system to the torque system to configured work instruction, MES capabilities. But the eKitting and eKanban also kind of falls into that, especially eKitting. The whole point of configuring a kit for a unit and then scheduling it so that it delivers on time before the unit actually arrives at that station on the line is key in terms of making sure you have a smooth manufacturing operation. And that's where this execution bit of PFEP comes in. As far as why we have this system or what drove us to include PFEP as a part of our solution offerings, as we've been talking, our system is primarily a process planning tool that lets you know what processes to conduct at different parts of the line at different stations. Each of these processes we've been talking about all day consume parts. Well, what does consume parts mean? Each of these processes call out for parts that need to be present in order to complete those activities. That demand of parts by unit at each station is kind of the reason why we went into PFEP as a company, right? We knew that with the detailed process plan that are taking place, are being defined at each station, we will have an idea of what parts are required at each station. We are configuring the process by unit, so we are model option mapping those processes, and we are saying exactly which activities to be conducted on the line for the unit that's coming down. So we will have an idea of what parts are required for each of those units. So that's kind of the driving force behind why Proplanner has a PFEP angle to it, has a PFEP solution being offered. In general, so the data was always there in Proplanner to justify having the PFEP module. But one of the main reasons that we went this route is obviously, with just-in-time delivery of kits and making requests based on when parts are needed, you're minimizing the inventory on the floor. You're not holding on to thousands of parts on the floor and just because you'll need them in the next week, in the next month, in the next planning horizon. You are minimizing the inventory of the floor. So you're freeing up space, and not only space, you're just not holding on to thousands of parts that you don't really need at that point. With the eKanban eKitting system, you're tracking those parts, where they are, where they went, how they got delivered to the line. We are accurately calculating the requirements on the floor with us knowing what units you're building, the schedule of the units, the part requirements of each unit. We are relying on the MBOM, on the bill of material that's in Proplanner, to tell you exactly what parts you need on the floor. So it's not someone creating a pick list or a list of parts to be delivered to the line. It's relying on the bill of material and using that as a backup, as the back end, to calculate the part requirements on the floor. And that's the next point, also configuring the kits by units and delivering just exactly what's needed. Quality improvement, as the operator is not second guessing on what parts they need to pick. When you deliver a kit to the line, and if it's unit based, then you have exactly the set of parts that are required by the operator for that unit. So you're not having to guess which exact board to use or which exact hose to use. It's all there in the kit. The operator can make the decision of exactly what parts are needed for that unit. We are calculating requirements of the parts. So since we know the units that you're building and we know your schedule, we can calculate how many parts are required for the given planning horizon, and then you can bounce that off of MRP and see if you have all the parts necessary. We can even start flagging which units we see on the line, on the schedule, where you'll start running out on particular parts, and start providing those warnings to the logistics engineers. So that's another benefit of having the PFEP system. We can easily manage schedule changes. So if today you are seeing a problem with the part of the line, or if you have a problem with a certain supplier and you're not getting your parts, and you want to move your schedule around, pull units out, put other units in their place, you can easily do that, and the system will just show you the picking related to those units that are in schedule next. So we're not publishing any information about this is the sequence of units, and therefore this is how you need to pick. We are doing this on the fly based on whatever units is scheduled next. So that makes managing schedules a lot easier overall. You're not restricted to a predefined set of units. Of course, by having a scanner app, we are not showing a paper or a list of parts for the operator to pick. I'm talking about the folks who pick the carts. The scanner app guides the picker to the right locations in the warehouse where they need to pick the parts from, and ensures that they pick the right part by scanning it. This reduces the errors in part picking, therefore improving the quality of the parts that are being sent to the line in terms of eliminating picking failures. So that's another reason, having an electronic device that tracks what parts you're picking. It makes it a lot easier and a lot more accurate for the picker. And reducing paper overall, doing everything electronically. And then the other benefit of this is with using the scanner app, a lot of our customers are trying to capture the information at the back that we are storing, like when the cart was opened, when the cart was closed, when the cart went into the docks, to the warehouse, to the line, when it got finally delivered, and when it was emptied. All of these stages from part picking to delivery to the line and bringing the empty back are tracked by the scanner. That data is available for analysis, and it lets you do it lets you do analysis on the efficiency of the whole process. Where are you lacking? Why is it taking longer to deliver to this stage of the on the line versus this other station? Why are certain carts taking longer to pick, and so on? So you can get into those efficiency calculations tied to the overall picking process also. Okay, so these are kind of the reasons why, other than just having the process drive the delivery, drive the demand of parts to the line, the overall PFEP process as to why it's justified to have this as a part of Proplanner. These are some of the main reasons for that. So I'll briefly go through what PFEP is. So in Proplanner, as I said, we are generating the demand at each station, right? By knowing the processes that take place at each station, we are saying, okay, for these processes, this is the net set of parts that are required at each station. If you saw the TEDx presentation today, that was one of the very important things for them to know is the part list at each station, right? So that's what we have with our process plan. Well, we're taking that part list and we're giving it a home in terms of delivery to the line, right? So we're defining what containers and carts you need to deliver it. We're defining all the locations, which are not only station locations or stations on the line where the parts are consumed, but warehouse locations, supermarket locations, transit locations, and so on. So, you can build all of that in our PFEP system. You can define supply systems, which is a key element, and I'll discuss that later here. But supply systems are basically methods of replenishing the line. You could have a Kanban system, you could have a kitting system, you could have a direct outside vendor to the line. You can have a unit kitting, which is a kit that gets added to the unit as it moves along the line, sequenced, and so on, right? So you could have multiple means of delivering the part to the line, and that's where supply system comes in. It's you defining those different replenishment methods to the line, and then you could have multiple kitting systems and multiple Kanban systems and so on. But the supply system is what puts all of that together and defines what part it is catering to and what kind of a system it is. We have methods in vendor management. So if you're tracking your forklifts or delivery methods to the line, you can define them in PFEP and use them as a part of your part plan. You can even go and say for direct to the line parts, or you can manage the vendor content also. And some of this is imported from MRP or can be imported from MRP if we have the right interfaces. The last three lines here about the actual work. So part plans is where you define the whole history of the part from where it came in to where it was consumed on the line. One part could have multiple consumption points on the line. One part could potentially have multiple delivery mechanisms to the line. So part plan is where you go in and you define the entire movement of the part from receiving to consumption. Material class determination. This is your ABC analysis. You can provide some information such as the size of the part, the cost of the part, how common this part is, and how many variations of this part are existing. Some of this information, again, as I said earlier, you can import from MRP, and then have the system compute for you what's the best way to classify this part, and therefore what's the best way to deliver this part. If a part is very commonly used, pretty much in majority of your units on the line, then maybe it's best to Kanban this and not put it in kits, right? Just have a big box of parts be sitting there and let the user pick what they need for the unit. If a part is very unique and is only used in certain units, there's no point keeping that part on the floor. Let's kit it directly from the supermarket or the warehouse and not put any extra space, take up any extra space on the floor. So all that determination of how to deliver the part and classify it in your ABC you can use the material determination aspect of PFEP. And finally, we report all of this information right from your transactions on the line for Kanban to your movements for kitting. All of this is captured, and I'll go through some of the reporting that we have available for that. So I want to focus on these three components for PFEP in a little more depth so that you can kind of see how this works. So the first is supply system. So as I was saying, that you can have multiple supply system types be defined. You have direct to the line, you have Kanban, kitting, sequenced, unit kitting, and so on. So you can, as you define a replenishment system, what you're essentially saying, you're giving the unique name, and you're telling us where the source of this system is. Is it supermarket 1? Is it warehouse east, west, whatever? So you're giving us a source to look for these parts, and then you're telling us the mechanism tied to that particular replenishment system, right? This is a kitting replenishment system, this is a Kanban, this is a direct, and so on. So this is important for us in terms of defining the part plans. As I said, the same part could be received in multiple locations, same part could be consumed in multiple locations. So it's very essential to understand what the source of the part is and give it a unique identifier, and that's what supply systems are. Next is part plans. So the part plan is the entire path of the part from birth to delivery. So you can see that I have a couple of parts here. They get received at K-stock, which is a stocking warehouse. They get put into this particular rack. They're delivered to this supermarket on this rack. From that supermarket KE7, that particular rack, they finally get consumed at that station, sub 15. So I'm not only, and I could have as many levels as I want in between of the entire delivery to the line, right? So it's a part plan is where the logistics engineer can really go in and make sure that all aspects of the part, from the time it's received at the plant till it finally consumed at multiple stations on the line, you have a part plan defined for each. You have a delivery method mapped to each, whether it's kitting or Kanban or so on, and that way you're not missing out on any movement of that particular part. A couple of things to note here is I could split my quantity. You can see that I have a quantity of 1 and 2 here. 0 and 1 here. So in the first case, since it's Kanban, I don't really care about a quantity. I'm just taking the whole box of 30 that come in and then moving it to the line. But on the other case, when I am actually moving the part as a part of a kit, I want to move one part at a time with every kit. So I'm consuming only 1 per kit. At this point, I could also go in and define if there's a split in the quantity consumption by model. So I can have model 1 and 2 consume 1 quantity of this part. Models 5, 6, and 7, I could say use 2 quantity of this part. So we can get down to that level, to the model and the option level, and have a different quantity defined per part plan if we want to. So the part plan is basically the movement of the part from end to end. The next thing that you can do in PFEP is, as I was saying, you can classify your parts. I think this is a key step in determining what the recommended, what the delivery method should be on the line. So I would like to say that we rely on a lot of MRP information back, especially when it comes to material cost, material size, weight, and so on. But once those parameters are in, you can define your thresholds in the system to say anything between $0 and $10 is cheap, and anything from 10 to 100 is medium, and so on and so forth. So you can categorize by weight, by cost, and then once you do that, the system looks at all those parameters and says, okay, based on the properties of the item, if there's as I analyze each item, I recommend that you do a Kanban delivery, or you do a kitting delivery, or you and so on, right? So this is completely customizable by the plant, by the facility. You can come in and define your thresholds. You can come and define your parameters. All we are doing is we're looking at the item. We are matching these thresholds, and if there's a match, we're saying we recommend that you do a Kanban delivery on this part, or you kick this part to the line. So this gives you a good way of making sure that every part that comes in new through ECOs or through product modifications do have a recommended delivery method, so that when the logistics engineer starts, you're not starting from scratch. You have a means of looking at what the system is recommending and then making decisions on how best to deliver it to the line. So that's another key aspect of PFEP in our system. So all of these things that I was talking about were tied to the authoring of data, so creating the PFEP data. As I said earlier, we have now, we used to have a Windows CE application, but we now have an Android scanner app. So all of the part picking and the Kanban execution that I was talking about earlier, you can now control them through this app. It's basically you can install it on any Android device. In this case, we have an Android scanner, but you could put it on a tablet and have a scanner tied to that tablet. At the end of the day, you launch the application and you're allowed to do both kitting and Kanban related executions from within that application. So that's a key development that we made in 2020. We moved from CE to having a true Android application. All right, with that, I'll go into what is eKanban and what is eKitting. Just walk through the cycle once, so for those who are not familiar with this, and make sure that you understand the background behind this. So eKanban or Kanban in general is a two-bin system, sometimes more, of notifying the warehouse or the supermarket of parts of part demands on the line, right? So imagine I'm working at a station. I have a bolt that I need to put on every unit. I see that I have one box of bolts remaining. I've completely consumed the second box of bolts. I'm going to make a Kanban request. So what happens is either the person doing the consumption, the operator, or there are folks who are monitoring the line and looking at the status of the containers, and if they see an empty container, someone will scan that. That action will print a label at the correct replenishment area. Again, depending on how you define your part plan, we'll know where to go, which area to go, and which printer to print on. That label will have information about the part, where it has to be picked from. Someone's going to grab that label, go grab the box of full parts, stick the label onto it, say that I'm done picking, or I'm done. I moved it to the replenishment area where it needs to be delivered to the line, and then finally scan it for delivery. Once they do, that box will go out. The box of full parts will go back to the line. So that's basically the process. Using our scanner to create the demand, track the full box of parts, and then finally get it delivered to the line. So if I want to see this through our scanner app, so you open the app, you go to Kanban, you have a Kanban general scan, which is the demand scan. Someone scans it, scans the label tied to the part that's sitting out there on the line. That generates a demand, prints a label out at this replenishment area. Someone goes in and finds that particular box, says, I'm going to release this box. I picked the correct box, and then finally deliver it to the line so that the full box is back to the line. And all of the steps in between, from the time it was requested to the time it gets delivered to the line, all the steps in between are tracked. All transits, all movements of the box from when it was requested to when it finally got delivered are tracked and is available for analysis if you'd want to check your replenishment cycles. So that is eKanban. The next is eKitting. This is a little more involved, obviously. So this system is relying on the knowledge that Proplanner has the MBOM. Proplanner has Proplanner knows the production schedule, therefore knows the orders that you're about to build. And a combination of these two, we essentially create a bill of material for every unit that you're building on the line, right? So we look at the order, we look at the configuration of the order, we know the model and the options, or just the model tied to the order. We know there's a date tied to the order, whether it's the offline date or the date that the unit enters the line online date. We know that date. So with the configuration of the unit and the date tied to the unit, we're able to accurately create a bill of material for that unit. So we're able to know that exactly what set of parts are required by that particular unit. We then look at PFEP. We know you have a part plan defined for all the parts that logistics is delivering to the line. And we create a PFEP list of parts for each unit, right? We're only looking at the parts that are required for that unit, filtered by the configuration, filtered by the date. So we now have information for every kit cart that's being delivered to the station for a given unit, what parts are required by that unit and how they will be delivered by kit cart on the line, right? So we gather all of that by looking at our PFEP data and the configuration of the unit. How does that look on our scanner app? So, we again launch the app, go to kitting, go to part picking. I'm a person picking the parts. I scan the cart that I need to open. In most implementations, the way this works is, in the warehouse, I could have multiple areas that cater to different sections of the line, right? So maybe stations 1 through 5, I'm in one area of the warehouse. 5 through 10, I'm storing parts in another area of the warehouse, and so on. Yeah. Or it could be the entire warehouse that I'm traveling through picking parts. It really varies, depends on how the logistics setup is done. But at the end of the day, as a part picker, you are responsible for a certain set of carts. You go to those carts, you scan that cart that's in front of you, and based on what's on the schedule next, we show you what parts you have to pick for that particular cart. We give you the part number, its description, where you need to go to pick that part, which rack and which slot, which units you're trying to cater. You could have a single unit cart, or you could have a multi-unit cart. What's the quantity split across all those units? So how many parts are you picking for each of those units? We show you an image of the part, so kind of poke your process to make sure you're picking the right part. Again, giving you a visual. And then we are also asking you to scan the location or the part number that you're picking, depends on a configuration here, so that the part number that's up above, you pick that right part or you picked it from the right location, right? So all of these checks are done before the part picker can actually place the part on the cart, right? You take your scanner, you go to your location, you find your part, you scan the location or you scan the part number. Before that, you look at a visual to make sure you're picking the right part. And once you're done, if everything matches, we let you pick that part. So that's essentially, our way of making sure that on the picking end, we are minimizing the errors or any issues that may arise due to incorrect parts by showing the visual, by requesting scans of the part number or the location, but kind of ensuring that you're picking the right part for this particular cart. So, and there are multiple functions here. As you can see that I have these two symbols here. So I can pause my picking at any point in time. If I'm supposed to go help someone else pick another cart because of an emergency, I can do that. So I'm allowed to get out of the system at any point in time. The bigger feature here is this dash or this minus sign that you see here. That lets me say that, okay, I'm supposed to pick one, I'm supposed to pick 10 parts. I only see 5 in the bin in front of me. So I'm just going to pick 5 and move on to the next part, right? So that immediately creates what we call a skip alert in the system, so that everyone from the logistics engineer to the supervisor is made aware that there are skips that are happening for a given unit or units. And I'll kind of show you later what that looks like. But right off the bat, because that's a reality, I may not have all the parts sourced correctly to that location, or someone may not have done a replenishment of the picking area. In either case, I'm allowing the picker to skip, to pause, and say that I don't have enough parts, but yet continue picking so as to complete that kit cart. And again, it depends on the environment or on the customer, whether someone should be allowed to pick or someone should just stop until the set amount of parts are delivered. So the scanner app allows you to do all this. And as I said earlier, all of this is being tracked. All the movements of the operator are being tracked so that you kind of have an idea of the efficiency of the process as well. With every scan that you're performing, we have some dashboards, and the resolution here is quite high, but essentially what you're seeing here is each one of these columns is a cart, and the rows here are the slots in a given day. The red band is around the slot for the current time. So everything above that has been picked or is being delivered, should be picked or delivered, because the current time of the day matches this slot. So if you see some reds, you know that there is a problem. Someone either picked a cart with a skip, or someone hasn't closed a cart that has been opened since morning. So the idea behind this dashboard is for the picking supervisor to monitor all the different pickers and see the status of where picking stands. And if you have a healthy band of colors at the top, that means everything was picked on time, got delivered. If you see some reds here and there, then you know you're having a problem. And this view, you can see that this view only has these 6 or 7 carts. The supervisor can have a view by line, by section of the line. So I'm responsible for the engine line. I'm going to create a view of carts that cater to the engine line only, although it's all being picked from this big warehouse. So I can select my view, and I can pick only those carts that are necessary for my picking, right? And I can kind of monitor those pickers and those carts alone. Along with that, there's another dashboard here, which is the delivery side of things. So, not only are we tracking the picking process, but we have transit scans put into till the cart is delivered to the line. So imagine if I'm in a warehouse where after the cart is picked, it's moved to the plant, it's signed off at the warehouse, it's received at the plant, it's kind of sorted at the plant and then moved to the line. All these steps in between till the final consumption of the cart, we can have transit scans, and then we can track the movement of the cart from when it leaves the warehouse till it gets delivered to the line. So again, we can track the cart movements that way, see when it went to transit A, transit B, transit C, till it was finally consumed or delivered to the line. So both aspects of picking and delivery are being tracked and are available as live dashboards for someone to review and refresh and to make sure that the process is on track. So that's on the kitting side. We also have dashboards on the Kanban side. So with every request that's made, you can see you can kind of gauge get an idea of how quickly your pans are turning from the time the part was requested to the time it was replenished and requested again. So if you analyze this information, you can get an idea of whether you need to increase your quantity on the line, whether you need to increase your pan size, or whether whatever you're doing now is adequate, or whether you need to reduce. Either way, right? If you're delivering too much and the requests are not happening that often. So same thing, with every scan that the operator is making on the line, we are monitoring that. We're displaying it on dashboards for your supervisor and the line leads to validate. Another report that I think is important from PFEP standpoint is looking at the impact on inventory, right? So how many parts do I need in this given planning horizon? What line is it for? What models am I building? What models and options? So given the fact that in Proplanner, we have the knowledge from MRP about your production schedule. We know what units you're building in the next week, next month. We can analyze the configuration of each of those units. We know the bill of material of those units. We know what parts are being delivered by PFEP, and therefore we can come up with a net quantity requirement for each of those parts. So as I was saying earlier, if you're looking at part shortages and whether you have enough in your transit or warehouse or on your line, you can run these reports and you can identify if there is going to be a shortage or not, right? So we roll up the quantities across the planning horizon that you're trying to look at. We know what parts are delivered for PFEP. We can add up the sum and we can tell you what the requirements are. as Dan was saying, we have pivot capabilities now in the system. This is a great example of taking this and comparing it to your MRP quantity data and see if you have enough or whether you're going to run out of parts in the near future. But this kind of reporting and export is available right out of the system. Another dashboard that we have is for skipped parts. So these are, if you recall them as talking about the scanner, if the picker does not see enough parts in the pan that they're supposed to pick, they can say, I'm going to skip. I only picked, we made it easier for the picker to say, I only picked 3. So the skip report will, if I was supposed to pick 10, the skip report will show a skip of 7 parts, right? So and it's real time. It's getting updated with every scan that's happening on the line. Anyone can monitor this report and see what are all the skips and whether they're being taken care of or not on the line. Along with, as there is a skip on the line, one of the things that we are also doing is we are printing a report right there and then with the scanner and kind of tracking it with the cart, so that again, another visual for the operator on the line to see these red boxes and know that there has been a skip on this particular cart, right? So you are aware that there's going to be a shortage of a certain part number that just got delivered to the line. So we're kind of doing it both ways. We have this dashboard that's being updated frequently or regularly to show you what are all the skips that are happening. And then on the cart itself, we put this kind of a report that shows you what parts were delivered, which of them were skipped, and what units were skipped. I think that's important to understand that where am I going to start seeing problems on this particular part. The last thing I want to talk about from a reporting and dashboard is as I said, we track, and I'm trying to make these bigger and smaller just so that you can kind of see. We track pick times, by cart type, by picker. So again, if you're trying to analyze your picking process, trying to make improvements on your warehouse, trying to see where the gaps are, why certain carts are taking longer than the others, all of this data is available for you to analyze and see where you can make improvements. So we have the pick times, we have the the quantity per across your planning horizon to kind of see which days I have the highest quantity of picks and how can I tackle that. Another information that you can use to plan your picking process and make sure you have enough manpower on those certain days for the picking. And then finally we have on the delivery end as well, how long it took for them to deliver, how many units they are delivering, and so on, right? So all of this information, since we are, as you're using our scanner app, we're tracking all this information at the back. This can really help in your analysis of where you can make improvements, on that side of the process as well. So I think that was my presentation for PFEP. As I said, it's trying to take your bill of material, your process data, match it up with what's really required on the line, break that down into kits and Kanban delivery steps. We are trying to move, and traditionally we have seen these being done in Access Excel kind of applications. So we try to keep a very spreadsheet-like interface where you can define many columns tied to the part, but you define the entire history of the part from receiving to delivery. But then we are helping through the process of automatically generating the demand, accurately calculating kits, tracking your Kanban and kitting requests, and then basically giving you reporting and dashboard out of this to keep on top of that process. Any questions? I'm going to stop here. Any questions on the PFEP process?
It looks like we do have one question. Just one second. Okay, the panelist has been able, or the attendee has been allowed to unmute themselves if they're ready to ask their question.
Hi, can you hear me?
Yes.
Yep.
Yes. I have a question on this PFEP. So on the apps, for example, on our line side delivery, I'm talking about for like the small parts, like the tuggers. If we're running out of parts low, does someone have to use the apps at the line side to scan, and it sends a signal to the tugger driver, says he or she would have to bring an additional box of small parts?
Yes, someone on the line said, and I'm not necessarily the operator, but someone who's monitoring those parts. Yes, but you're right. We will have to have a scan from the line on the Kanban side of things to generate that demand, to generate that fall.
Okay, because the way we currently do today, I don't know if you're familiar, I'm pretty sure you're familiar with it. We have a min and max process. And usually our tugger driver will go to the line and says, okay, I need X amount of these parts when it comes down to whatever that min may be. So if the min is 1 or 2, he or she will go grab those parts. So if that means someone on the line has to scan these parts to send a message to the tugger driver, says he or she needs to start picking these parts and deliver to the line based on what your PFEP app process. Would that be correct?
Right. So I think if your concern is with someone having to scan every time, yes, right. If you're using the Kanban mechanism, someone will have to scan, and that generates the demand. We do have another supply system called AutoPick. This is at one of our customers right now, and this goes by tracking the inventory of the part, right? So if we and setting min and max on that. So if we see that 10 units have gone by at a station, and we received an inventory status, say 1 or multiple times a day. As we receive the inventory status, typically from MRP, we know the number of units that have gone by, we automatically start deducting from the inventory status that we receive. And then when it reaches the min, we automatically send a signal to, in your case, the tugger driver to say, bring me a box of, to reach the max again. But,
so pretty much that would be a PPS system, right? With the auto pick, that means as you're setting up a production post system that if you consume 10, it's automatically going to send a signal.
Right. So the only reason I didn't talk about it earlier was this relies a lot on someone giving us the accurate count of inventory. Whereas in our scanner, we are having someone monitor that and say, yep, I'm running out, I'm going to scan again. But if we have an interface with some system that says, as of this morning, I have 1,000 parts, whether it's in transit or at the location or the warehouse, and now you build 20 units, so your 1,000 has come down to 500. Well, 500s are min. Let's go request another one at that location, right? But we need that information, the current status information, either once or multiple times a day, depending on how frequently this part is moving, right? And so, instead of a scan, we will need that count to make that decision that yes, we need to make a request now. I don't know if that makes sense.
Okay, no, that makes sense. Thank you.